Hello, my name is WingItMan. Let's make... Hold on. Electricity. Electricity. That's more like it. I forgot to disable the script. Oh, we're going to be making this today. Again, for me. I had to make this video about 6 times. Yeah, all sorts of problems with it. This is the actual scripts that we're going to be making. I'm showing this first just in case you want to skip past the whole video and make it yourself. But yeah, this is the function, and let's get started. So firstly, in this episode of Let's Make, again we're going to need the Properties window, we're going to need the Explorer window, Advanced Objects, and the Output window, just in case we have any problems along the way, which I more than probably would. Anyway, remember these windows, you can find them if you go to click on View, Explorer, Properties, Output, and for Advanced Objects is on the Model window. So, let's get started. I'm going to get rid of this script first, so just so we can start anew. And I should probably tell you why I got these two bricks in. As you saw a second ago, we had a little display of lightning, and I'm using these two bricks here to display that whenever we test. These are just normal parts, nothing special about them. Anchored parts, floating in the air. One's called Part 1, the other's called Part 2. And I've made some different colours just so I can distinguish which we're starting from and which the lightning will end, or where it'll go to. So if you want to make that it'll be easier for you to test your scripts when it comes to testing. Okay, back to the making this script. So we're going to be making this script in Service Script Service for now. So click on Service Script Service, and in the Advanced Objects, click on Script. Get rid of Hello World, and first thing we're going to start off with in making is a folder that holds all the lightning parts in it. So local folder equals workspace find first child lightning debris, we'll call it, or instance.new model workspace. I'll give the folder a name. Now you might be wondering, David, why are you looking for something that is not there? And what's this about? Hold on, let me just copy this. What's this about or instance.new? Well, if it can't find lightning debris, it just skip over to this half of the code and then create a new model that we can put our stuff in. It just saves about 5-6 lines of code that we don't need. Okie dokie. Right. Estimate the actual electricity part. So local, we'll call it bolt equals instance.new part. And we're not going to give this one a parent just because we're going to be cloning this part and using it in the scripts afterwards. This just helps to keep things clean and separate and know what you're doing. The name, we're going to call it electrode or something like that. Let's give it a brick colour, make it nice yellow. Oh, I love these little pop-up windows now. Robots is added. Great. Bolts.transparency equals 0.5, we'll say. Now this thing we will need, it's called form factor. Pardon me. Form factor equals custom. This just allows me to change the size to something smaller than 1.1. As you can see, the smallest size on symmetric form factor is 1.1. If I turn it to custom, look at it, it's tiny. Okay, so we'll leave that as symmetric for now, but that's just a handy little thing. It's going to set the can collide to false, and we're going to make it anchored. Great. We'll put the size to a vector 3 of 0.4, 0.4. You can change this part. It's up to you. Brick color, transparency, all the above here. Is up to you. Okay, let's set up the events and functions. So function shoot electrode from to. Don't forget your pronunciation with scripting as well. Roblox won't find unquoted things, things with improper names. So remember to get your capitals and stuff like right. It is very case sensitive scripting. Sorry about that. Right. And we're going to make our while loop. This is just for testing purposes at the moment. So local from equals workspace dot part one. Oops, part one dot position. Local 2 equals workspace dot part 2 dot position, and shoot electrode from 2. Okay, so that's the event setup. So now whenever we run this script, it's going to fire this function with these two values, from being from and 2 being 2. Okay, now let's get to the actual script, the actual function. A few things you probably won't understand at first, but I'll try and explain it as best as I can later in the code. So first thing I'm going to write is last pos equals from. As I say, we'll learn what that is after. Local step equals, we'll put it at 16. Step is going to be when we shoot our electricity from the first part to the second part, the first point to the second point. It's not going to just shoot one straight line, one continuous line. It's actually going to be in what I call a step. So it's going to go here, then it's going to go here, 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 etc. Or in this case, it's going to go from 0, 16, 32, 64, and it's gonna look more realistic when we add these things, and it also helps it to travel faster when you have a higher number. Anyway, next thing we're going to need is a for. Next thing we're going to need is the distance. Local distance equals from -2 dot magnitude. Magnitude, according to the Roblox wiki, is a term used across mathematics that means several things. In vector theory, or in positions we're using, the magnitude of a vector is the length of a vector. The length of a vector is calculated. Oh no, I'm not reading that bit. But we're just getting the distance from the start, or part 1, and 2, which is part 2. We're just getting that distance. Okay. Now we're going to make a for loop that scans from the start in a continuous line to the end. So this is what the for loop is going to do. For I equals 1, 0 to the distance, at a rate of step. At a rate of step. Great. So it's going to start at 0, it's going to end at distance, and it's going to end every time this loops around. It's going to add. As I say, if this is this distance is 64, it's going to go 0, 16, 32, 64 until it gets to its endpoint. Excuse me. Right. Local. Oh, don't want to write it there. Pardon me. Local. Local. What am I doing? Local from equals last pass. And local 2 equals. Pardon me. From plus minus from minus 2 dot unit times step. You're gonna love this one. All this basically does. All this, as you can see, we've got from. This is this current position along the line. This is it. Say we're at 0. We're at the starting position. So we're starting here. From is equal to from. Oh, sorry. Is equal to here, and 2 is here in the direction of here. Times step. So it can be moved 16 steps in front here. So it's going to be about here. Okay, this is the 2 is now the direction it's heading in. You'll see in a minute. Right. Now let's make the actual electric part. Local P equals bolt clone. P.parent equals folder. Okay. For the size, we're going to leave it at its original size, but obviously we're going to change the last value so it looks like it's making those steps properly. So p.size equals vector3.new, and because its size is already set, we can just go size.x, or the first value, p.size.y, the y value, and so we need to go from again minus 2 dot magnitude to get the distance between these two values, these two vectors, and that will make up the distance between each step, and that will look smooth and lovely. Okay. Two more things before. Well, one more thing before I test this script out. It's a cleanup I'm going to be using. Something I'm going to be using for cleanup is called game.debris, which is a service on Roblox. Add item. Oh, just one thing. If you ever get stuck on what a certain function does, or if you're trying to look for something, just have this this Roblox GUI pop-up thingy highlighted, and it will show you exactly. Well, for most items, it'll show you a description of what that function, that event does. I absolutely love this little pop-up window. It's a brilliant idea. Thank you, Roblox. Okay, let's try that. So we're going to have it be destroyed after 0.5 seconds. So let's test that. Where's me run? There we go. So let's see. Oh, I forgot to add C-framing, didn't I? Oh, sorry about that. Oh dear, I'm tired this morning. Right, p.cframe equals cframe.new. Sorry, cframe.new. Remember your capital letters, people. Roblox won't find it if you make that little def mistake. I've made it loads of times. I'm not kidding. Now we're going to be using another little event, little function in Roblox. It's called lerp. So we're going to go from lerp from full colon lerp to 0.5, so it should look like that. Copy that in, and I'll show you what it does in a minute. And then after that, we're going to put a comma, and then we're going to make it point to the direction. So this is the exact position where the the part is going to be, and this is going to be the direction. That's basically how C-frame.new works. The position and the direction. Now, lerp, according to this, it returns a vector lerped between this vector 3 and the goal. Alpha, or this 0.5, should be between 0 and 1. So what that basically means is going to, if I set the alpha, this part, to 0.5, this is going to, and I set this part, it's going to, between this part and this part, from here to here, it's going to, if that alpha is 0.5, the part is going to be smack bang in the middle. If the alpha is 0, it's going to be at the beginning of the part. If it's at 1, it's going to be just about at the end of the part. That's all that lerp does. It's a transition between this where you're from and where you're going to. That's basically what lerp does. Right, now we've fixed that. Now let's test it. You should be able to see. Ooh, that's one big part. So, for some reason the form factor doesn't work, but never mind. As you can see, it's pointed in the direction we want it to go. It's gone from here and lerped to here, so its actual position is about here. But it's not stepping forward. Why is it not going anywhere? Is it broken? Well, if I move this part, you can see it's not broken. It's still pointing in the direction. What we forgot to add was last pos. Now, I'll explain what last pos is now. Last pos is a method, it's an open variable that I use to remember where we was last. Pardon me. As you can see, I set last pos to from at the beginning, and then from equals last pos, and at the end now I'm going to set last pos equals 2. So as you saw from that lighting, it went from here to here, and then I'm going to set last pos to that position, and then when this script loops round again, it's going to go from here as to its last position to its next position, and then it's going to keep going along until it gets to our part 2, and that's all last pos does. It remembers where it was last. Let's try it. There we go. Fantastic. Oh, let's see if it works. Yeah, there we go. So we're going to make the now we've made the electricity go from here to here. Well, it doesn't look like electricity, does it? So what can we do about that? Oh, let me just fix that. Form factor needs to go before size, otherwise it'll set to 1, 1, 1. Anyway, how do we make it spark and go all over the place? Well, use another vector 3. So I'm going to make a variable outside here called local off equals, I'm going to put it at 32. That's going to be quite a big offset. And just before this variable, this 2 line, we're going to make a value called local offset equals vector3.new. Now for this point, I'm going to drag this last bracket down here just so I can read it a bit easier. it can be kind of awkward to read this because it's quite a long bit of code. We're going to be using a equation called math.random. Math random takes a variable between one number and another number, and then and then returns a number either equal to one of these or in between those two numbers. So if I say it's between 1 and 2, it'll either be 1 or 2. That's what it will return. If I put minus off and off, it's going to choose a number between minus 32 and positive 32. And this just gives the spark that we want. So I'm going to copy this because I hate typing this bit of code. Remember to leave the comma off at the end and to put it at these two lines. And before I do anything, let's divide that by 10 just so it looks a bit smoother. And we're going to go plus offset. Okay, let's try that. Play. And look at that. Is that awesome or what? Yeah. And that goes quite a distance. We don't want to go so far. Let's just fix that. So, just so the game doesn't lag out, we're going to add another value called range. I'm going to set it to 500. Pardon me. Let's see. Here we go. If distance equals more than range, then distance equals range. That's all you need to have a range cap. Let's try it. Pardon me. So that's between its range. That's between its range, and we should see it pulling back. There we go. As you see, it wants to go as far as possible, but it just can't make it. That's probably double the distance. So that will cut down significantly on lag as well. Because if you noticed before, this was kicking about 8% of CPU power, CPU usage, and it's only supposed to go up at 3%. So yeah, you need that. Okay, I think that's pretty much it for this episode. I'll leave it there. But in the next episode, I'll show you how we can use this bit of code in more ways. This has gone on a bit long. Sorry about that. It is kind of a little bit complicated code to explain. But thank you for watching, and I hope to see you in the next episode. Bye bye.